First of all, good evening, good afternoon to everybody in India and who else has joined from elsewhere. This is for me a fantastic webinar, so I'm greatly looking forward to it because we all talk about hydrogen and make believe it's like the next substitute for natural gas, but it isn't. Hydrogen is quite different in terms of its physical and its chemical properties. And this needs to be observed when we're designing projects because we can't just replace it one to one as much as we would love to. Hydrogen, and I'll provide some details. It was written in the invite, but why? Hydrogen has a much wider range of inflammability, which means it ignites much easier, leads much easier to explosions. Hydrogen is a minutely small, if it is the smallest molecule in the universe, which means leakages happen much more often. Materials, hydrogen can diffuse through materials, make it much more tricky to deal with. And so, but we still want to do it. And let us not forget that, especially in the refinery industry, hydrogen has been used already for a couple of decades. So it's important, therefore, to learn from that experience. Um, and because we really have that experience, we have a two-part seminar. We'll be talking firstly about the safety standards, what needs to be observed. So what can the public sector do to ensure that certain procedures are followed to avoid accidents? But then also practically, okay, standards is one thing, regulations all good and certain, but how does industry actually protect itself and ensure that workers and its own assets remain safe? And for that, we also have Baker Risk. I'll introduce you separately. I first like to provide, when it comes to the standards piece and regulations piece, we have today with us Karen Kotadia, from CEW. CEW is the think tank Council for Energy, Environment and Water. We've collaborated with CEW in the past. We've also, CEW has already prepared actually a document where it reviewed international regulation standards, compared them with India, and therefore came up with a gap analysis. And I'm very happy to have Karen Kotadia with us today. Energy economist, I think that's the title. Kill me if I'm wrong, but I'm far away. To
Uh,
join us to lead us through.
yeah, thanks, all. Good morning to you. Thanks to you, Nishant and Path and of course GH2 India organization for giving us this opportunity to present. Good evening, good morning, all. Depending on where you are and which part of the world. I'll be presenting today on green hydrogen standards, regulations, and testing infrastructure in India. My name is Karan Kothadia. I am a program associate at the Council on Energy, Environment and Water, an engineer by background and a management consultant before working at CEW. So, the Council on Energy, Environment and Water is on a mission to impact sustainable development at scale with data, integrated analysis, and strategic outreach. We have three pillars of work: transformations, which entail transformations in the economy, in your energy markets, power markets, in your industries, and in your livelihoods, which affect the quality of life and for which these transformations are necessary. Parameters like air, water, foods that we eat, how and in what forms can we afford cooling and mobility, are the topics studied under these pillars. And enablers help us do all of this. Enablers such as finance, technology, future, circular economy, climate resilience, and international cooperation. We're a 330 plus multidisciplinary team right now, with four special initiatives, a lot of research across the board, be it publications, reports, data transparencies, dashboards, data sets, roundtables, conferences, and host of other outputs as well. We've engaged with 20 plus Indian states and have been part of 160 plus bilateral and multilateral initiatives. Um, I'll, I'll talk today about standards, about testing infrastructure and approval systems in India. I would like to take questions at the end, so please keep a note, and I'll be more than happy to take any questions at the end. Um, so, firstly, on Indian standards related to hydrogen, right? So, hydrogen is not a new commodity in India. Standards exist. We've been using gray hydrogen in refineries and fertilizers. That's why standards, a lot of Indian standards on safety and performance exist across the value chain. If you see, we have balance of systems, hydrogen generation standards, we have transport and storage standards, we have end use standards, and we have safety standards as well. Indian standards, the IS standards are issued by BIS. International standards are also adopted in India by multiple regulators, be it ISO, EN, IC, ASME, AG, and the others, right? So we have a host of standards already in place. And popular ones such as an ISO 19880, which deals with fueling, is present by the name of IS 18538, right? BIS has contextualized it for the in the Indian context and published it as an Indian standard. Similarly, IEC 60079, which is the safety standard, is present under the code of IS IEC 60079, right? So like I said, hydrogen is not a new commodity and standards exist. The gaps are where hydrogen use cases are still being developed, right? For large industries, these standards are fairly common, they're fairly widely adopted. But where new use cases of hydrogen are emerging, like for instance in a steel or a mobility or other consumer applications, there the development of standards is something that we have to focus on going forward. India collaborates with multiple international entities on hydrogen standards. So if you see, there are a lot of entities in the North America, Europe, and Asia that India collaborates with. Indian entities such as the Bureau of Indian Standards, which is the national standards body of India, which also partakes in the ISO and is a signatory to the ISO. The Oil Industry Safety Directorate, which is a body that formulates and coordinates, implements self-regulatory measures for the oil and gas industry. The Petroleum and Explosive Safety Organization, as the name suggests, deals with explosives, compressed gases, and petroleum products. The Ministry of Road Transport and Highways, under their ARAI entity, issues and adopts mobility related standards on hydrogen. And the PNGRB is a nodal agency that deals with petroleum products and gases. And it is a consumer redress agency as well as an agency for ensuring fair markets in these commodities. So all of these entities have some standards that they've issued or adopted on hydrogen. Uh, One thing that we have to note is that standards aren't rules, right? By convention, standards are not something that that an operator or a user of hydrogen necessarily has to abide by, right? Sometimes these standards can be enforced when is which they become rules, right? That is when these standards actually have to be implemented by the rule of law. Otherwise, standards can also be customer enforced. Performance standards, a lot of times, customers require you to meet certain performance standards, and that's why you would want to get yourself certified along those standards, right? So we have to make this clear distinction between what a regulation is and what a standard is, and I mean that's some nuance that usually gets lost. With these standards, however, one major gap that we identified was that if you see on the chart on the left, right, we have adopted or developed a significant number of standards already. Some were under development, and this was in May 2024. So, huge probability of these standards also having gotten published. Yeah, I mean, that's fairly probable. There were suggestions that the MNRE had made to standards issuing entities for adoption of 58 standards which were globally present, and to develop standards where there were no global standards on three commodities. So if we see that there has been a substantial progress on standards, but not much on testing infrastructure for these standards, right? How do these standards get certified is something that we are seriously lacking. in comparison to these 207 standards, only 53 standards had some sort of a testing agency or tests identified in Indian testing agencies. And there were some bodies that could be approached, public sector bodies that could be approached to test against these standards and issue certificates, right? For any third party entity also to verify whether they're meeting the standards or not. We seriously lack testing infrastructure. That's a big gap. If you see globally, there are a lot of testing facilities. Some are private, some are supported by governments. But there are a lot of these testing facilities across the value chain. But in India, we see that the number is far fewer. We have an NPL and a SECRI. One is a private lab, one is a government lab, which has facilities to test against the standards. So as compared to the US and the EU, we have very few institutions with testing facilities in India. The problem with this also is that we don't have models where collaboration between project developers, between manufacturers, between OEMs, between design and engineering firms, between academic institutions and research laboratories can be facilitated to ensure that standards can happen, right? There's no sort of a platform where we can know what sort of facilities and equipments do each of these entities provide, and in what forms and factors can these entities actually help us conduct these tests. So that's another that is how the gap in testing facilities also manifests. Moving on to jurisdictions, we've seen that there were about 90 permissions that were required for uh, green hydrogen projects across the value chain. I'm saying if you take a part of the value chain, then those number of permissions might reduce substantially. But across the value chain, if you were to add up, there were about 90 permissions that were required, of which the state governments hold the most number of hold jurisdiction over the most number of approvals that are required. Now, a lot of these are administrative approvals as well, relating to the way businesses are conducted, right? But there are six safety-related permissions required from central government authorities like a DPIIT, the Pollution Control Board, the DGCA, and the Petroleum Explosives Safety Organization, as well as seven safety-related permissions from state government entities, which is the Factories and Boilers Inspectorate, the Chief Electrical Inspector, Director of Industrial Safety and Health, SPCB, State Fire and Emergency Services Department. Now, if you will notice over here, a lot of these entities also deal with large industrialized setups because that is where hydrogen was primarily being used in India up until now, right? But moving ahead, as we develop new use cases, as we develop new industries that will hold, consume, and use hydrogen, we will need to update this with a very fast pace, right? We'll proactively have to uh, preempt what sort of standards, regulations, approvals, and tests we are going to need, and act accordingly. I'll finally conclude with some imperatives that we see for green hydrogen standards and permissions development. First is addressing gaps in standards in a timely manner where there are no standards existing in the Indian context is a priority. Developing testing infrastructure for critical components for performance and safety standards is also a gap that we see and a major one. Subgroups on standards for upcoming applications, like I mentioned, on shipping, aviation, rail, and if I may add, also on upcoming consumer applications, be it mobile stations or microgrids, is something that we'll need to see. Uh, we see a need to expand mandates of regulators and labs to include green hydrogen. What happens in public sector entities is that they act according to the mandate that's given to them, right? They don't have much leeway to regulate, or and rightly so, they don't have much leeway to regulate something that's not in their mandate. So from a policy perspective, this is this is a key point that we'll have to address. Developing an online portal for green hydrogens with associated information is something that I've kept on the slide, but I've marked in green because the NGHM with its resources has already started doing that. But there are gaps still in the exhaustiveness of that information on the way that it's accessible to the larger public. If I were to modify this point, I'd say improving that online portal is imperative, and fostering international collaboration and incentivizing private sector participation are is the last imperative that we see for this development. I'd just like to share that we have a couple of studies that we've already released on this topic. One is a co-branded, one is a study that we've co-authored with the MNRE, which is the Green Hydrogen Standards and Approval Systems in India. So this is an India-focused study, largely based on the database that MNRE holds on these green hydrogen standards and the activities that it has conducted on this topic. And the second is titled Accelerating the Implementation of National Green Hydrogen Mission Assessment of Standards to Enable the Ecosystem, which is a first principle technical document on what the scope of these standards are and what the utility is and where are the critical gaps. If you would like, you can scan the QR code and get to read our publications. With this, I'll just pause with 1.5 minutes to go and hand it over back to the moderator. Happy to take any questions right now or even later as well.
Given you've been so quick in time, is there any immediate question somebody would like to ask? Then otherwise, I would be happy to pass on. So I'm just opening it up. Does anybody have an immediate question? I always have tons of questions, so but I'll keep them for later.
Sure.
No, okay. Then if you could stay here, it seems as though he has any immediate requests. Then let me introduce them, the next team. We are joined by two speakers, actually, not just one, but two speakers from Baker Risk. So I have to also honestly admit, I didn't know about Baker Risk previously, but I read your website, went through the things, and this is just like almost an answer to all my safety nightmares is because Baker Risk is, for those who don't know, has been for 40 years now specialized in process safety management. They work a lot with the oil and gas sector, and I'm sure if they work with oil and gas, they have to also deal with how to deal with hydrogenation and desulfurization with hydrogen in refineries. So these guys are like some of the few people who know actually from practical experience about hydrogen. So most of us deal with PowerPoints, but these guys are much better. These are seen and done it people. And that's why I'm looking really forward to learning from you guys today. Therefore, we're joined by a team of two, if that's correct. We have with us, let me get my notes. We have Murtuza Gandhi, who is the manager for qualitative risk and sustainability. We also have Peter Diakov, who's the senior consultant for Baker Risk. But I think that's it. So Jatin Shah is not joining us, I believe, today.
Correct.
Just
Yeah,
the two of you. Okay.
Yeah.
And so these guys, my guess is, but I think they've got so much to talk to. So my hope is then we'll talk more about process safety management in general. And the other thing is these guys have been working for 3 years now also in Egypt with hydrogen. And so hopefully they will tell us more about their practical experience in Egypt with hydrogen and specific applications, which is, as I've been from my brief notes told, ammonia, green ammonia. So this is like absolutely cool. And with this, over to you.
Thanks for the kind introduction, Rolf. Karan, very good talk, very insightful. Thanks, Nishant, Parth, and the GH2 team for inviting us to this presentation. I'm Murtaza Gandhi, and my colleague Peter Daika will tag team in this presentation. So let's go, Peter. Okay, so this is just a little bit about myself. Been in the industry for 20 years. We can keep going. Okay, so just a brief introduction about Baker Risk. We are a 100% employee-owned company with offices in North America, Canada, UK, Egypt, and the UAE, and hopefully in the future we start our operations in India as well. So looking forward to it. What we do, we are a full-scale consultancy and a testing organization. So maybe Karan can add the Baker Risk test facilities to the map that you had earlier as well. But yeah, we have a research wing, we have a consulting wing. We build software and tools, and then we are also into products. So we have products for buildings that are good for multi hazards like explosion, toxics, and fire. We do a lot of courses as well. So Learning Center is one, and this is just the industry that we have. So today's talk, we want to discuss a little bit about the specifics in safety about around capital projects. So when you are, as Karan was mentioning, there are a lot of new cases that are going to come up in the industry on all sides of the spectrum, and so. How does safety play a key role in all those different parts of the life cycle is something that Peter and I will discuss. So that's the overall layout. So why do we care about safety? I guess we get asked this question a lot because right now the challenge is as you're developing these new use cases, there is also a challenge of finance, right? And so the impact of safety sometimes is felt as if it is a cost, which it is, but the importance of safety or not doing that, not doing the production, not doing the transport or the use of hydrogen safely can create a lot of issues. And so safety, so these are the few key points that I've noted here. Safety, of course, for employee and public safety is important, and that's true everywhere in the world. Economy, so you want to build a sustainable and a profitable industry. So one bad incident, can really impact how the industry or how the general public thinks about an industry. So it's important to build it in a sustainable manner that can continue to grow. The other thing is the energy. So we are going to create different fuels out of hydrogen, right? Ammonia is already one, methanol is one. There are others that are going to be formed out of just creation of hydrogen in different forms, whether through green hydrogen. The idea then is how do you produce those safely, and are you aware of the various hazards and risks there? Public confidence, I spoke about the cost and the infrastructure. So creating an infrastructure and having it adapt to the different use cases in the future is absolutely critical. So we don't know where the industry is going to go, where the different use cases are going to come from. So doing it safely is going to give us a longer runway in the future. So very quickly, I want to talk about the PSM framework. And the PSM framework, I'll try to show it from two different angles. So this is the OSHA PSM. OSHA is the Occupational Safety and Hazards group in the US, which regulates a lot of the workforce type applications in the country. So they have 14 elements, and the different elements talk about the various pillars, which includes, process safety information, meaning all the drawings and things, the process hazards analysis, training, how do you manage your contractors, how do you deal with hot work permit, management of change, incident investigation is a big piece of it, and then auditing to make sure that what you've done in terms of your projects is auditable, is trackable, and that is done correctly. So there are these different elements of PSM which apply, and I'm sure that there are similar elements that are also globally adopted and adapted. And those have to be applied to the hydrogen industry as well. There are certain threshold limitations of how much quantity of hydrogen do you need to have to apply these. But in general, it is always a good practice to adapt these techniques into your application. Next slide, please. Yeah, so this is just from Center for Chemical Process Safety. So they have these 20 elements. These pillars are very similar to the ones that I showed for OSHA PSM. They are slightly more detailed and organized in a different manner. And then there is also a chart by Energy Industries Council. They are all good practices, but then also a lot of them are regulations in different parts of the world.
Great, thanks, Murtaza. So I'm going to talk a little bit about project life cycle and safety life cycle for capital projects. So as we all know, there's many stages to the capital project life cycle, and the type of technical safety studies changes depending on where you are in that process. And so it's really nice to be able to perform these different studies at the different stages and be able to build on them as you go through that life cycle. It's almost an evergreen process, because if you think of a cycle, it's not just end, it kind of continues. And so I'm not going to go through all the possible technical safety studies, but I'll highlight a couple of these because we're going to go through a little bit in detail in them in the next few slides. So some of the ones I want to highlight include hazard identification and risk analysis, so things like PHAs, HAZOP, LOPAs, code reviews, whether that's for standards or regulation. I know we talked about the difference about standards and regulation in the last presentation. So doing that early on is really important. Optimizing your site layout and spacing in terms of equipment, but also overall facility layout. Fire protection studies, emergency response planning, occupied building siting, sometimes referred to as facility siting and quantitative risk analysis, and then future construction and turnaround planning. Now, it can be really useful to use a stage gate review process to identify what studies should be performed depending on which part of the project lifecycle you're in. So I really like this matrix here because it gives a good visual representation of what types of projects you can do at which stage. So you can see that when you're early on in the project lifecycle, front-end loading or FEL, you're doing mostly conceptual or preliminary type studies. At this point, you're able to have more flexibility in terms of changing layout and spacing, maybe even the process, depending on the hazards and risks that you're able to identify. And then as you go through your FEL and then into project execution, your ability to make changes to your design and to your facility layout, they are decreased. But you're able to increase the accuracy and the detail of these studies. And so one of the really important points of this whole stage gate process is that as you go through it, mitigating risks and hazards and those hazards that are identified become much more expensive when you're in the project execution side. So looking at these safety studies, technical safety studies early on, really reduces the overall cost CapEx wise in terms of mitigating those hazards. So if you're able to use a stage gate process where you're doing preliminary studies, identifying hazards, and able to make changes, that's going to be much cheaper in those early stages than it is later on. And so using a process like this is really helpful from the whole project lifecycle standpoint. We're going to talk a little bit about some examples of assessing hydrogen hazards and mitigations. And so we'll talk about a couple particular studies or safety studies. And so Murtaza is going to start at first with talking about PHAs.
Yeah, so a very high level PHA is what you're looking at, unmitigated risk and mitigated risk. Unmitigated risk is what is my worst case credible scenario? What is the worst case severity of that scenario? And then how do I mitigate that through my safeguard? So you look at all the different failure modes. So for an electrolyzer, for example, you would look at what kind of equipment can that fail, right? So if you have a stack in the electrolyzer, can that stack fail such that the hydrogen and oxygen can mix together? Or if you have a membrane failure where you have diffusion of hydrogen into oxygen or oxygen into hydrogen and can form an explosive mixture. If so, what are your protections? Do you have gas detection? Do you have vented panels for explosion protection? Do you have any sort of exclusion zones that you have set up so that you don't have the blast impact people either in occupied buildings or in outside process areas? So that's a typical analysis that's done in the oil and gas industry, and that technique is used in different industries as well, but primarily for assessing the hazards and risks. So you can determine what my risk gap is and then look at how you can mitigate that. Yeah, so again, these are details on it, and we can probably go through it in a separate presentation. But yeah, so I think that the key nuances with hydrogen is what we need to be concerned about. So can you directly apply the techniques and the tools? Yes. But do you have the correct understanding to evaluate using those same techniques or not is important. So you need to have some background in handling and assessing hydrogen risk, and then understanding what kind of different risks are you going to see. So for example, very easy example that I give is if you are at a petrol pump, and at a petrol pump you have petrol which can leak. If that petrol leaks, you know that there is a potential for a fire there if it gets ignited. But that fire is going to be limited to a pool. But that same thing, when a hydrogen leak happens, the potential for an explosion does exist. And if that does exist, then how do you mitigate that? All the things, any new technology that you introduce is going to bring some challenges with it. And how do you mitigate those challenges with the correct design is something that a PHA-like technique can help.
We're going to talk briefly about facility siting and risk analysis. So similar to PHAs, where we're evaluating the hazards and associated risk, facility siting is that, except much more quantitative. So we're identifying the hazards from the normal operation of the facility and looking at the impact of the at specific receptors. And so what those receptors are going to be changed depending on what the objective of your study is. So we talked about different regulatory requirements around the world. If you're in the US, typically you're looking at people on site, within the fence boundary of the facility. In other regions of the world, regulations require you to look at impacts on people off-site. So making sure that your facility is not providing undue risk to people off-site. And so the takeaway from these studies typically are numerical estimates of risk exposure. And so if we look at some of the outcomes of facility siting from a consequence basis, they typically look like consequence contours. So here we have some examples of thermal radiation contours from a site, flammable dispersion contours, and overpressure contours. And these contours aren't from multiple events happening at once. It's a composite. So typically you would model individual events occurring the same way. So you find a max credible event or an individual loss of containment scenario. You look at all the different ways of the consequences from it, and you can overlay all the different scenarios that you evaluate in the study to find the maximum extents associated with the operation of the facility. Now, if you take that information, you go to the risk side, you're getting those numerical estimates in terms of risk exposure. So either societal risk, which typically is in a fatality per year unit, or individual risk, which is an annual probability of death. And so whether you're looking at individual risk or societal risk, really what you're trying to do is make sure that your risk is not excessive, and it's going to either fall in the tolerable if ALARP, or it's simply low risk and it's acceptable. And there's a number of different ways you can do that. Some common ones would be individual risk from a work group standpoint. So making sure, a particular job category, whether that's an operator or a truck driver or an engineer that's on site, their job is not incurring excessive risk. You can also look at risk in terms of locations. So whether it's a building or a process area where people are spending time, making sure that location does not incur excessive risk. And so you can look at risk from different ways, but at the end of the day, you're really comparing to some sort of risk tolerance criteria, a threshold, to make sure that you're keeping people safe, either on-site or off-site. And so I wanted to kind of come at this from a little bit of a more practical standpoint. We've talked about hydrogen, but within industry, there's a lot of interest in ammonia from an energy carrier standpoint, being able to convert the hydrogen to ammonia and then ship it off to different locations. So I wanted to highlight some of the differences between hydrogen and ammonia. So the first one is evaluating explosion hazards. And so as many of you may know, hydrogen tends to burn very, very quickly and can be quite a large explosion hazard. I'm going to show a couple videos to highlight the difference between the explosion hazards associated with ammonia and hydrogen. So the first one is a test that Baker Risk ran that would be representative of a process building or a process enclosure where you have an accidental release of ammonia. So you have a loss of containment scenario. The ammonia mixes with air, creates a worst case concentration. It ignites, and then you have an explosion. What we define in this case as a vented deflagration, where the overpressure is going to fail. In this case, a plastic venting face, and then the fireball is going to exit. And the takeaway from that should be that burned very, very slowly. And so ammonia, because it burns so slowly, tends to be, you can, from a practical standpoint, you can use deflagration venting to mitigate the hazards of an internal ammonia explosion. Obviously, if you have no venting, that pressure inside of the building or enclosure is going to build until something fails. For a typical constructed building, the entire building is going to blow apart. But because ammonia burns so slowly, it is much more practical to be able to design engineered venting to be able to mitigate the hazard associated with overpressure. Whereas with hydrogen, that tends to be much more difficult for large releases of hydrogen because it burns so quickly. So this is the same configuration as the last case, except we've done hydrogen within the enclosure. And this is not even a worst case hydrogen release. This is a fuel lean mixture, so not as bad as it could be.
Wow.
So
that's quite a difference.
It is quite a difference, and that difference is also present outdoors. So we've run similar tests because you have operations outdoors, you have process units outdoors, and what we found is that ammonia tends to not really be a significant vapor cloud explosion hazards when released outdoors. Because it burns slowly, it basically burns as a flash fire. And so here's an example. So it can be a flash fire hazard. However, it's not going to produce overpressure that's damaging to buildings or equipment. Whereas with hydrogen, the same rig, actually, this rig is even less conservative because there's no wall at the end. You'll see that it's quite a different experience. So I played that video twice to highlight that even with a fuel lean mixture, that's not your worst case. Hydrogen presents a much more significant explosion hazard outside. Now, on the flip side, if we look at acute toxic hazards, hydrogen isn't considered an acute toxic. But ammonia is. And so I've provided some context here, some typical thresholds for reference in terms of the acute toxicity of ammonia. Things like your acute exposure guidelines, emergency response planning guidelines, the IDLH value or the current OSHA PEL. You can see from these different values, they have different applications depending on what you're trying to do. But in all cases, the required that results in an action level or results in fatalities, it is quite low. And so we're dealing with the toxic hazards. They're in completely different realms.
So yeah, in general, from the videos and the tests that you saw, we basically the tests that the ammonia tests that Peter showed were just recently completed. We've been doing hydrogen testing for many years, and it's done as a part of something we call an explosion research cooperative. So there are about 22 global companies that participate in that research with us. And we run the research program for them, and those are the different things that they ask us to study. And one of the so we try to understand what are the different pressures that you would see from hydrogen explosion, from ammonia explosion, from other gases too, from natural gas. So if you were doing blue hydrogen and you were using natural gas as your feed, then in any of those cases, those studies are done primarily to understand what the risk profile is going to be. So from a risk consideration, the flammability and the fire explosion, occupant vulnerability, in other words, is the probability of death. But that's that study. The toxicity and the toxic occupant vulnerability. There are different parameters like the ones Peter showed. There is ERPG, AEGL values, and things like that. So how does that impact the hazards? Now, the one interesting thing here is that when you are talking about green ammonia, of course, for any ammonia process, you have hydrogen as one of the feeds. But in traditional ammonia plants, what you had was natural gas feed coming in, and that was piped in through a pipeline, and then you were converting it into hydrogen and then using that hydrogen for your ammonia. But in this case, when you are going to use electrolyzers, the hazards, the high pressure storage hazards are critical because to avoid the fluctuation of the supply, you may need some high pressure storage. And so those storages, and then you may also have large ammonia tanks at your facilities. So siting them properly, making sure that you have protected your people from both a toxic as well as explosion hazard is important. So the design of the layout of how you lay those, the plot plan of the facility, how you lay out the buildings, how you design those buildings, and how you adjust the occupancy. So one of the things that Peter showed was the different work groups and how those work groups get impacted. So how often do you need people to go into the electrolyzer building to do some maintenance work? All those things will have to be considered in determining your risk profile, as well as offsite population. So a lot of these things, on-demand hydrogen production is coming up in more populated areas. It's now getting different. We used to have hydrogen hazards in the industry, in refineries and large plants, but that is changing. And with that change, the occupancy profile is going to change. And with that occupancy profile, the risk is going to change because risk is directly a function of the number of people it can impact. So with all those considerations, we want to close out to say, yes, it is a different type of a hazard, but not that has not been known, and there are techniques and mitigation methods to prevent as well as mitigate them.
Thank you both Murtaza and also Peter. This is absolutely amazing. I mean, the way the videos is brilliant because it just demonstrates many of the things that would be so much more complicated to say really with words. So brilliant, well done. As I said, I can always ask questions. So this Q&A time, you finished early, so we have actually almost 40 minutes, more than 40 minutes left. Yeah.
Rolf, if I can come in.
Yes, go ahead.
Thank you. This was very exciting, and thanks for having those videos of things blowing up. I think that really added to the elements here. I'm very glad that, everybody who joined us at the beginning are still here. So you've got everyone's attention. This is a key topic. It's very important. I have some questions for Karan, but I see some people in the audience who are quite experts in the field. Dr. Chitra, I know you're there with us. If you're available, and if I could ask you some questions, if you could draw parallels between what you've seen here and what really exists here in India, that'll be really great. So, ma'am, if you're available, can you let us know if you're there?
Can you hear me now?
Yes.
Yeah.
Yes, Dr. Chitra.
Yeah, please.
Ma'am, you've seen what Baker Risk has presented and what Karan had given as an outline of what the Indian standards are.
I missed the earlier part, just the earlier 15-20 minutes I missed, but I was able to see the rest of it. Yes.
So, ma'am, if you could give a little bit of a background of who you are and what you've done in the space, and then also your comments on what you've seen, and where do you think we can take some action steps together to enable a good ecosystem for safety in hydrogen in India.
Thank you. I think that was an excellent presentation, and especially the field trials which were carried out. Basically, are when you actually see it, you appreciate it much more. So yes, I think the differences between hydrogen and ammonia and the way they behave, they have been very well illustrated. As far as India is concerned, yes, we have been doing a number of studies. We have looked at it in the past also, the entire life cycle, both from the storage, transportation, production, and end use. We've carried out safety studies, we've carried out hazard analysis, and we've applied various tools and techniques. What we've been saying throughout is that use a systems safety analysis approach, a systems approach, because it's a very complex problem. You have a number of interacting, you really don't know how they're going to interact together. And I think the last speaker, what he brought out was very valid, that now it's going to get out into the public arena. So far, it was in the industries where you had trained workers. Now we have workers, we have public who are going to be, let's say, in a refueling station, and then there would be the public outside the premises. So there are three types of risk basically. You have the involuntary risk of people who are really outside the premises, who are nowhere connected to the refueling facility. There are the second set of people who are coming in for refueling. And then there is a third set of people who are working there. So the risk levels are basically different for each one of them. The problem here is we do not have risk acceptance criteria. So we need to look at international criteria. And even in the international arena, I do not see these three types of risks defined anywhere. So basically, we are looking at other industries and sort of using the risk values there. The second set where I would probably request inputs from the learned speakers would be the data, failure data for components. We were talking of electrolyzers, we were talking of all these new kinds of equipment which we are going to use now. We do not have reliability data, we do not have failure data, with the result that if we want to do any kind of analysis, if we want to sort of do a fault tree or find out the frequency of events, it's very difficult to do so. Thirdly, even accident data is not available. We do not have a system for gathering it, and also because the kind of data is rare, any kind of analysis or statistical analysis with the data also becomes very difficult. So those are just some of the off-the-cuff remarks I wanted to make, but I would like to ask the speakers who had shared their experiences with them as to how they feel we should go about these challenges.
Yeah, excellent questions, Dr. Chitra, and very well articulated. To the first question about the risk tolerance criteria, that is something that the industry is kind of developing. So there are certain risk tolerance criteria that have been developed for fueling stations. They are handled slightly differently. So the various standards that are there, some of the NFPA standards, and then how they've been used by organizations like the EU and others. They have taken some of that information to say, okay, this is the incremental risk, but the risk tolerance criteria has not changed. What has changed is how do you get to that risk tolerance criteria, right? So they've said, we still want the probability of death to not increase just because we are adding these things. But then what that does is it puts onus on the industry to say, if I still have to meet that criteria and I'm here instead of here, I just need few more layers of protection to be able to bring it to that point. As far as the different work group risk and whether there is an off-site and an on-site risk component, yes, there are certain criteria globally that, and those are mostly driven by the industry themselves on what they accept it as the risk tolerance, right? So in many cases, in the US, there is the OSHA RMP as well as the PSM. So the PSM is generally for within the facility, and RMP or risk management plan is something that you provide for off-site risk. So there are certain and mostly industries will use their own criteria to say this is what we can tolerate. It's a very, very complex subject. We are helping clients right now with it, and it takes a lot because it's not just showing that they value safety, but then how do those numbers get interpreted by agencies? How do that get interpreted by judges? Things like that. Those are all complex problems that that you deal with. So that was your first question. The second question about the failure rate database. So we have a pretty extensive database that we have used and developed for the known failure modes, right? Of known equipment. But the new equipment that's coming in, the electrolyzer stuff, and it's not new, it's been there, but the use cases were different. So the failure modes and effects analysis has not been as rigorous as you may need for what you are trying to analyze. So what we are doing is we are trying to work with OEMs on developing some detailed FMEAs and break it down into subcomponents where the failure rates are known. And once you start adding those up, you can get to some sort of a statistical number, which is closer to reality. Because right now, if you poll the OEMs, they'll say, "Hey, our failure rates are extremely low. We don't get any returns. We don't get any complaints." But they may not know that the end user may themselves be fixing it, not even conveying back. So that data, there is a disconnect there. So yeah, that's kind of what we are doing. We are working with most electrolyzer OEMs globally known, and are doing those subcomponent FMEAs to help determine what those failure rates should be. And then where there are gaps, testing is going to be important, because there is definitely going to be gaps, and those are the gaps that testing will have to close.
Yeah.
Does that answer your
And
question?
yeah, thank you. That was quite comprehensive. The third thing was about the accident data
Hmm.
and the analysis of that data.
Yeah. So, I mean, there is, what was that website, Peter? I think it's called h2tools.info.
Yeah,
That
I've taken a look at it.
you've
Yes.
taken a look at that. Yes. So there are some accident databases. CHS, Center for Hydrogen Safety, is a very good repository of some of that, because and they do regular webinars as well on the various failures that happen in the industry. We do have some internally collected as well, because we do accident investigation as a part of what we do. So we have some of that collected as well, but I don't think there is a comprehensive database, if that's what you're looking for. The industry will have to come up with, and I think there are different forums that are trying to do that, but it will need to be looked at from a geographical and from an industry perspective. And I think there are efforts ongoing in that direction.
Thank you.
Thank you, ma'am. Karan, you had your hand up. And Rolf,
Yeah,
over to
thanks.
you for the rest of the session.
Thanks, Nishant. I just had one quick question on Murtuza's point on failure rates. Now, with all these digital industrial solutions coming into place, is there a way to collect failures, information about failures in distributed setups over digital modes? I mean, I may just be hypothesizing, but have you come across any such solutions or use cases being piloted elsewhere? Anywhere?
Um, Not particularly, Karan, not at the moment. I
Mhm.
I think technology is going to play an important role on collecting and parsing this data.
Mhm.
But I think it's the lack of data. Like Dr. Chitra said, there is not much out there, and that's the problem.
Yeah, fair. Thanks.
There was one aspect, couple question which I had, if I may. This is about the effect of human factors. How do you embed human factors in design, and do you take cognizance of this when you do your designing and project design as well as the detailed plan design?
Yeah. Peter, do you want to take an initial stab? You are muted if you're talking.
Yeah, sorry, that was a little bit choppy. Apologies for something IT issues. Can you restate the question?
Yeah, this was regarding how do you take care of human factors and human reliability analysis during your plant design?
Yeah, human reliability is a really interesting one. That is something that's I think that talked about a lot in industry, and there's more background there, and that can be applied to these studies. But in terms of actual examples, I'm kind of drawing a blank. Murtaza, any thoughts there?
Yeah, so I think, Dr. Chitra, the easiest example that comes to mind is loading and unloading, right? So now we are going to unload or load, transport hydrogen tube trailers to different places. So and then if you go into the liquid hydrogen space, that gets even more tricky. So in those cases, how again, if you start with the risk tolerance criteria and you say, to my truck drivers or to my loaders and unloaders, I don't want to exceed that risk profile. You start going back to say, how do I mitigate that? That means, am I going to need two people instead of one people supervising that operation? Am I going to need a larger exclusion distance? Am I going to need more training? Am I going to need different types of hose connections for them? So the ergonomics, the human factors of how they are running their operation will have to be charted almost in a very organized manner. And then wherever there are gaps, add redundancies to minimize those is something that will have to be concerned. So you mentioned about fault tree, and there are methods like the Taseo and the HART methods and things that help develop or calculate that human reliability factor. So in a stress environment, in a low stress environment, how are they going to react to it? Are they well trained or not? Are there enough alarms and mitigations? So if you are going to put gas detectors, are you going to put it in the right location? If you're going to have them put something on combustible gas detectors on them, are they calibrated? So the things that you can instrument out to take the human factors out, you try to do that as much as possible. And then for the human factors, you train them to the risk, to the hazard, and help mitigate that.
Thank you. I was thinking more in terms of inherent design features, to take care of human failures. So there are certain types of failures which, through an analysis, you can make out that these are the type of failures humans would be prone to in a certain situation or in a certain environment. So you design it out, make it safe to operate or user-friendly plants. So do you take care of that at that stage, or if you have some thoughts on that?
Yeah, very good point. So yes, the most of these electrolyzer containers are now being designed to be operated kind of almost maintenance free. So their life cycles are developed in such a manner that you don't have a lot of replacement. You don't have a lot of you don't have to go and lubricate things, or you don't have to go and remove filters or mold sieves and change and do things like that. So what they do is they say you can run this electrolyzer nonstop for, let's say, 6 months. And then at the end of 6 months, you shut everything down and you go in and you do your maintenance once and you come back out. So that is something that's increasingly being done. There are good and bad with it, right? When a human does not put their eye on it, things can, and you are relying completely on the various sensors. There are sometimes challenges of things that tribal knowledge doesn't come in, people don't see it, and failures can happen. But if you've thought about those things in your PHA and you start designing your systems to be operated almost maintenance free, then that's very well done today in the industry as well. So yeah, I think the biggest change right now is how you design your like the deflagration panels and things like that. Because what you want to do is when you have like your gas detectors go on and you want to keep your concentrations of hydrogen. So if you have a leak, you want to keep the concentrations low, you start your ventilation system. So there is a lot of new things that are coming up in ventilation design, in gas detection systems, so that you can kind of operate these without any intervention for significant periods of time and reducing the risk.
Thank you.
Murtaza, Rolf had a series of questions, so perhaps Rolf can come in with his questions, and then we have some Q&A. We have some questions in the Q&A box as well. Rolf, over to you.
Yes, okay, thank you. Yes, sir. We've been looking at more very abstracted process safety management. Since you've worked in Egypt, or can you, from any country where you've set up a hydrogen with safety systems for hydrogen, be it in a refinery or ammonia plant. What are the experiences you've had, or what are the specific things you've done to make the plants safe?
I think it is not one thing, Rolf. Like you can understand, right? It's a series of steps, and you start with both the qualitative and the quantitative risk analysis. So the PHA, which is the qualitative, and then the quantitative, which is the facility siting, which Peter mentioned, and then look at, be realistic in it. Don't take every scenario to death and destruction, because that means that your list of recommendations is going to be huge, and you will not know how to prioritize those recommendations. So being realistic and being practical in your studies, but also have the understanding on and the impacts of hydrogen safety, doing that right, I think is the first step. As far as some specific safety systems, so like I mentioned, I think the biggest things that I'm seeing change right now is the NFPA 68 and 69, right? The 68 is vented deflagration panels, and 69 is the prevention piece. So in both those cases, with the 68, designing of the deflagration panels right, how you tether them so that if you do have these panels lift off, they don't impact people, and how you site them is important. And then on the prevention piece, your gas detection and your ventilation system. So doing it with more high fidelity models like CFD inside those containers to say, yes, this is how the gas cloud is likely to behave. And then based on that, this is where I'm going to place my detectors so that I can get the coverage quickly, and then I can initiate shutdowns quickly. Those are some of the major changes that we are seeing in the hydrogen world for safety systems. As far as the implementation in Egypt and elsewhere, I think there are no real differences there. I mean, whether it's US, Canada, UK, India, or Egypt, I think it everything works towards the risk tolerance criteria. So whatever that is defined either by the government or by the industry, that's what we kind of aim for. And we, where practical, we look at solutions where we are much lower than that risk tolerance, but at least try to achieve the risk tolerance criteria.
Okay, that's reassuring to know that it doesn't matter which country, the standards are the same, point blank.
Yeah, absolutely.
And the risk tolerance is pretty much all the same. I have a question here. I will deviate from my own. Somebody's asking, can you tell us where safety certifications are available that would help upskill professionals? Because I think that's what everybody's worried about, and this could be either for those conducting the design or for those operating the systems to avoid the human factor or reduce the human factor.
Yeah, so I mentioned Center for Hydrogen Safety. I think that's a premier organization that has a lot of courses online that provide that type of material. We do online courses as well, and we are actually collaborating with organizations to disseminate some of that information as well. So more to come on that in the future. But yeah, CHS I think is one of the ones. There are universities. So I know Peter and some of my other colleagues went to University of Houston as well, and so there are other universities that provide certification courses too.
Okay, thank you. I'll come back to safety courses a moment. I'll make sure to bring in also Karen for a moment. Since we're talking about safety courses, one of the questions I saw was, which testing areas would you recommend? So safety is more the prevention, but testing is more like the pre-step of how do you make sure the equipment is actually safe to be used? So what areas do you see would be, based on the review of standards, which testing areas would be needed?
Yeah, thanks Rolf for the question. The way we see it is depending on what part of the value chain do we want to specialize in and focus on, we will need to develop enough testing infrastructure to support that, right? So, for instance, if we were going gung-ho about manufacturing of electrolyzers, fuel cell components, and then exporting these components or just creating a market for those, we need a lot of OEMs, engineering design firms to collaborate with institutions, either academic research institutions or public sector units, or however we can, to be enabled to certify on the behalf of a regulator and say that this works, right? That linkage between a regulator and these entities, which are private entities, which get contracted by industries on their own volition to do their own safety checks and not necessarily to provide a certificate to the government, is something that's missing, right? Like Murtaza said, that we are also doing testing, but would a government accept that the results of those tests? Maybe in your case they might, I'm not really aware, but a lot of these institutions that also do testing don't get recognition from the government that this is a valid test or not a valid test. So capacity building in that sense is predominantly required. So like I said, for manufacturing, if you were to think of manufacturing of components, fuel cells and electrolyzers are critical, and their components and materials that make those things up, right? The entire supply chain. If we were primarily looking to use, then components on end use application, be it storage systems or refueling or injectors in different technologies, testing for those also will be required. They are largely industrial scale, so different sort of entities are involved in testing there, as against a consumer facing entity. I hope that does that answer your question in part.
I'll go no more specifically. So now let us assume for the moment that I'm now coming from I'm a ship owner. And I believe that shipping is going to be the next big thing, especially green ammonia. So the question is, where would I go to get my green ship tested, or especially my green powertrain on the ship tested? And the second question to Murtaza, so my seamen are scared shitless to work on a ammonia ship because they think it's toxic, they think it's dangerous. So what would I do to, let's say, allay the fears, or what kind of training could I give to my seamen? So a double question. First Karen and then Murtaza.
Yeah, you're putting me in a tricky spot, Rolf, because the short answer there is the end use application testing facilities, if there were one, we have not come across anyone who has certified that we'll do this test for a hydrogen system or not, right? Could be that we simply don't know that they have the facility and that it can be used for hydrogen testing, but that connection is something that at least I'm not aware of. Dr. Chitra has raised a hand, so
let's give
ma'am, please, if you would, like to support.
Basically, this is coming up. I think the government is well aware that these facilities are required, and therefore a testing scheme has been released. That is, the proposals have been invited for testing and certification. The first point you brought out was whether the test results would be recognized, whether, unless you're certified, they won't be recognized. So that is part of it, testing and certification. So I think a few months ago, there has been a scheme released by the MNRE under the NGHM, National Green Hydrogen Mission, for test and certification facilities, calibration, and so on. The idea is that there are already some facilities existing within the industry which could be upgraded. And there may be some new facilities which may need to come up. For example, I think the question was about shipping. So this is something where there is a lot of, in some pilot projects are being taken up on shipping right now. And testing and certification would certainly be required. And ammonia is also, in fact, if you look at the site program, we have hydrogen and ammonia. There are two separate aspects. So this is also being looked at. But yes, right now on the ground, there are a couple of people who have said that, yes, we are setting up the facilities, but I do not think that it is at the stage where you can straight away.
So thank you, Professor Chitra, for the answer. Sorry I put you on the spot, Karen, but it sometimes helps to get practical. Now I'm putting Murtaza on the spot.
Yeah,
No, I
the
think that's
seamen. Yeah. Uh, yeah, that's so the one thing that I that I've heard on various in various conferences is that the ammonia has yeah, it was, maybe not, anhydrous ammonia was not transported. Now, I, my understanding is that ammonia as a fertilizer is much more common in the US than globally. I think probably in the EU is also common, but globally it has been, not used as much as a fertilizer. But in general, the transport of ammonia is something that has been done through the
That's
ship
true.
for a long period of time. So they know the hazards. They know that there is an known incident history. Um, yes, it has not been as widely done as it may be in the future. I think the bigger difference is going to be the bunkering piece. So now that you're going to have
Agree.
ammonia bunkering at these different ports, the risk profile there is going to change. So um, uh, uh, but that is something that, again, it can be managed as a bunkering facility, making sure that the risk is considered in the design. So how you have your marine loading arms. Do you have any sort of mitigation there for, if you were going to do any water mitigation or toxic shelter in place, things like that, as long as that is done on the port side. On the ship side, using the information or using the incident history that is already there, training personnel before they go in and carry these as fuel, I think is extremely critical. So it's a huge endeavor and it's going to take a lot of time, but it's not an unknown entity.
Yes, no, I'd agree with you. I think ammonia, what is little known is that of the 200 LNG ships today, roughly 40 on average will always be transporting ammonia. So LNG ships can carry ammonia and vice versa. And so there is experience in ports in processing. Mostly there will be ammonia terminals, which, I mean, a ship may take 2 tons, 2 months of production. So the operations will not happen that often. Therefore, bunkering will be more tricky as operations refueling would be happening more often. And the key issue I agree with is really on the ships, how to make the seamen feel safe, especially if ammonia is then used as a fuel rather than put into a tank and closed. And then you simply have operations.
Yeah.
That's obviously. I may be putting you on the spot again, Murtaza. So, what are, if you know, I mean, we're talking again very abstractly about processes, but what is the, even if incidental history of accidents, if you know any, with hydrogen, to give people a sense, at least, of what has happened in the past?
Are you talking from a shipping perspective or in general?
No, just in general, just in general.
Okay. I think there have been quite a few there. Again, I think I point you to CHS. CHS recently did a webinar. I missed it, but there was one failure that they mentioned. There was a vehicular failure very recently somewhere in EU area where the hydrogen tank, I think. I don't think it exploded. There was a fire, but the venting happened for a significant period of time to get rid of the hydrogen. So those things are happening now, more often than not, because I think there have been some incidents in California as well, because in California, within the US, that's the area that's growing. We've been working with University of Texas at Austin. They have a center developed called Hydrogen at Scale. And in that hydrogen at scale, they test these types of. So they've been doing, actually, I didn't know, but they had been doing testing on hydrogen fueling for buses for the last 15 years. So recently, I got a chance to take a ride in my first hydrogen vehicle over there. It was a Toyota device, I mean, a Toyota car. And so they've set up where, they are working with the Department of Energy, DARPA, and others to determine if you have leaks at these points, what does that look like, and especially at the refueling station. So I think there is some research. There have been some incidents in the industry, and the thing is that because it gets a lot of visibility, those incidents are almost immediately in the media. and are discussed very openly in various forums as well. So the one that comes to mind very recently is the one in the EU area about the hydrogen tank fire, but there are others that have happened.
Oh, yeah, so sorry if I put you on the spot. I was trying to arrive at exactly the same conclusion, but actually the fears around safety or dangers of hydrogen are, I think, much larger than actually the number of incidents that have actually happened.
Yes.
And I think that's perhaps important to emphasize that the safety procedures developed in designs and operation generally have worked. I mean, and therefore people can take comfort in these procedures and to avoid things happening. Practically, I've heard also the incident in California. I've heard also something, I think it could have even been Germany, I'm not sure.
Yes.
But I think there was also an incident also in South Korea on the bus. But these
Correct.
are all
Yeah.
more small fires. Nobody got hurt. No major damage. When it comes to shipping, since ammonia ships have been happening now for ammonia has been carried for ships, I actually did some research. And the worst incident I found was actually when two ships in Germany collided, but there was damage to the ships, but there was no damage to the environment or to anybody else.
Yeah.
And that is because when you come to ammonia tankers, they are usually, you get into, as you call it, system design. So I just explored that out of curiosity. They have double-hulled ships. That means that even if the outer hull gets pierced, the inner hull containing the ammonia is actually still safe. And so that's just one of the safeguards employed to ensure, which often gets forgotten.
Yeah. No, absolutely.
Yeah, so just to reassure people, while we are talking about safety, I think the key message, if the procedures are followed, then actually industry and science and engineering has figured out ways actually to deal with it safely. I'm looking at the chat and I don't find anything. I'm not sure if Peter is still there and he can hear us.
I can.
Okay,
Hopefully you can
brilliant.
hear me.
Yes, no, we can. So I don't want to make sure you don't get forgotten either. So you did these wonderful videos. Perhaps tell us a little bit more. What kind of conditions did you have to create these, let's say, stimulated explosions?
Yeah,
What kind of accidents were you simulating?
Great question, Rolf. So there is a general desire within industry to continually improve our modeling methods and educate those within industry, because at times you get skepticism on the hazards associated with hydrogen. Obviously, we've been dealing with hydrogen hazards in the refining and ammonia fertilizer production for decades, but we do see new entrants into this space with these new applications, and with that you get old questions coming up about well, does hydrogen, is it really an explosion hazard, or does it just drift away because it's so buoyant? Things of that nature. So we have run a number of test campaigns to try to both improve the models and methods we use to model the hazards, but as well as to help people out there in industry understand these hazards. So some of the ones that we've been running recently are the confined or enclosed test cases. And so the ones I showed there were for an enclosure that was about 48 feet long, 24 feet deep, and 12 feet tall. So it's approaching the size of maybe a compressor building. But we've also run tests on more containerized sizes. So if you imagine either fuel cell or electrolyzer equipment that's based in kind of Connex size containers, we've run tests on those types of containers as well, because we're seeing these containerized solutions becoming a popular option within industry. And so looking at what potential releases look like inside, the impact of ventilation, what a real release looks like and ignition versus a more of a delayed case where you mix to a worst case concentration, and the impact of vent size on those types of situations. And so there's a lot more work to be done, but we've done a lot of good work in this area, and it's valuable because we can start to see how these different tests are representative of different types of units and process areas. As I showed, we've done outdoor area type tests. So the one test that we showed you that was outdoors for hydrogen, that was the rig was almost 100 feet long, but it was only 6 feet tall and 12 feet wide. And so that's more representative of where you might have an outdoor process area. And so we're striving to try to do more realistic, more representative of real process units. But of course, depending on the technology and the types of facilities, it's always going to be a little bit different. So we then benchmark the data back to our models to make sure that predictions match what we're seeing in the test configurations.
Okay, sounds brilliant. So you tried to make it as realistic as possible, and you didn't use Hollywood technology to come up with a 20-centimeter model that you then blew up in the camera to make 12 meters. Okay, so it's very real. Great to know. I still have just checking if anybody of the participants would still like to ask a question. So let me check with Professor Chitra Rajagopal. Are you fine? Anything that you would still like to ask?
That's just a comment. This was about the ammonia. You had mentioned, shipping in ammonia. I thought I'll just like to share that 3 of the ports are already coming up. That is Kandla and Tuticorin, and I think one more is there. Paradeep probably, which are being prepared for, So they are already being, in the, they are already preparing for green ammonia. And as you said, there are already people who have a lot of experience with ammonia. Incidentally, in India also, a lot of ammonia is being used for fertilizers. So there is a lot of industry experience available in India. But now I think they have to translate it to, using it in the ports and training the people there and developing the facilities there.
Exactly. Thank you. And then just to add on, yes, India is probably the largest importer of ammonia annually with a total consumption of 18 million tons. 3 million is imported. So India is a great importer, and therefore it has facilities. I'm also seeing a Dr. Gopala Krishna Achara, who I'm just calling up if you wanted to make sure, since we have you also as a distinguished participant, if you would like to ask any question. I'm putting you on spot. I hope not. Okay.
Rolf, there are some questions in the chat box.
Okay, sir. I'm going through the speakers. Okay, the chat box. So, there's a question. So, is PTC available for performance test of electrolyzers, and which PTC is available? Being asked by Dharmendra. So I'm actually at a loss what PTC means. I hope that you gentlemen know. Performance test of electrolyzers.
Yeah, I'm not familiar with that terminology. But yeah, performance testing, we're not into that, so I wouldn't be able to.
Okay.
Rolf, there was one question by someone named Vidya Chavan about mitigation methods for populated areas, and I think if Peter wants to take that on, if that's okay.
Okay, I missed the one. Then please go ahead. Yes, no. Peter?
Yes. Yeah, that's an interesting one because it goes back to. Can you hear me now?
We can.
Yeah.
Excellent. Yes. So that's an interesting one because it goes back to what Murtaza was talking about for in terms of risk tolerance criteria. And so the idea of looking at your off-site impacts in some cases from a regulatory standpoint, or maybe from an internal requirements to try to reduce off-site impacts. And so when we talk about mitigation, it really comes down to being able to have a solid understanding of what is driving your risk. You can do that from a what we call a source risk standpoint, where you look at what portion of your operation is contributing the most risk, what equipment or what operation, whether it's a loading or unloading operation, or whether it's compressors or it's the storage, what is driving your risk. And once you understand that, you can it will help you guide the mitigation efforts. So obviously, the easiest one or the simplest one, I should say, which is not easy, is increasing standoff distance. The further away you get from the hazards, the better off you are. But particularly in applications which tend to be more public facing, we're seeing that standoff distances can be very limited. So then you look at options for actual hazard mitigation. And so, do you have a jet fire hazard? So what type of mitigation options are there for trying to prevent that? Maybe for smaller releases, things like firewalls might be able to prevent the thermal, the fire hazard from providing significant thermal radiation off-site. But when you get to explosion hazards, it might be a little bit more difficult. So you start looking at how Murtaza had said, maybe deflagration venting or suppression, prevention. How can we look to mitigate if you have enclosures, how we can mitigate the explosion hazard associated with the enclosure? If you have outdoor releases, there's been some really interesting work around gas fences. The idea that if you have a high pressure release, can you have some sort of porous fence that's structurally sound that basically stops the momentum of that high pressure dispersion, so that rather than reaching very far off site, or reaching equipment that would accelerate the flame if burned, you actually dissipate the momentum of that release and allow that hydrogen to vent away. When we talk about public-facing locations, you also look at typically you might have venting requirements. So whether it's PSV or PRV, pressure safety relief valves, for the system, siting of those vent systems is going to be important. You want to make sure that you're not from a design release case, you're not producing or adding any risk to people on site or off site. So one of the key features to trying to mitigate risk to people either on site or off site is really understanding what's driving that risk, what type of hazard, what part of the operation, and then focusing and developing mitigation strategies particular to that situation. So unfortunately, it's not a one size fits all, but there are good options out there.
Okay, thank you. I think it's good to know, because those are probably, when it comes to ammonia or hydrogen, the biggest issues. What you do if you're located close to populations or other issues that could actually suffer and you don't have the space. We're getting down to 4. So just for the people on the call, this bit, 4 CT, or this is now already 8:30 India time. So I'd like to make it a fairly punctual close, but I still would like to take the one last question that's in the chat and then close the chat. The question is, so we would like to know about the use of fire water spray system, sprinkler system, CO2 footing system for hydrogen generation, compression, and storage area. So what type of fire safety systems would Baker Risk recommend?
So I think the fire risk typically is managed by your extend distances. It's because the fire, if the gases are unignited, can result in an explosion. The most really is done is cooling of equipment and shutting down. I have not seen a lot of fire mitigation strategies. Maybe that's also because the explosion risk sometimes supersedes a lot of the fire risk. What I've seen from fire, we've done some fire testing as well. That the fire is not going to be visible if in certain conditions. So you have flame detectors there, trying to look where the leak spots are. As far as the pure mitigation strategies there, I'm not the right person. I have other fire protection experts that I can poll and come back to. So if the person can provide their email or something in the chat, I can come back to it. But I've not seen that many fire protection strategies as much as I've seen the explosion.
Good. All right, so I think that's a fair answer, and probably the explosion risk is for bigger ones because hydrogen explodes very quickly. With that, people, can you
I
please?
think Dr. Acharya would like to.
So
think
would
he-
you? Okay.
You wouldn't
Regarding
be.
the fire, I can just add on a little bit because we were looking after fire safety for nearly 3.5 decades, and we were also looking at this. So basically, hydrogen fires, you don't fight them. You protect the other appliances and other equipment around it. And you try to put off the gas, or rather use your isolation valve or something and put off the gas as soon as possible because you do not want any more leakage to take place. So that is the first principle, that you don't really fight a hydrogen fire. You rather cut off the supply and then cool the equipment around it so
Makes
that
sense.
that doesn't.
Agreed.
Yeah.
Yes.
So we are located in Bangalore. We are trying to set up a test facility for testing of internal combustion engine on ammonia or on hydrogen.
Okay.
And we need some support on the safety and handling of it. And we are based in southern part of India, Bangalore.
Okay.
Sure, Dr. Acharya, we can put you in touch with Murtaza and his team at Baker Risk if you want.
Right.
If you want to have a introductory call.
Okay, thank you.
Thank you.
Thank you. That's all. That's my query. Bye-bye.
Thank you, Doctor, and good luck with your project.
Good. Thank you for letting us know. Good to know that the testing facility is being developed. Good. With that, please, whoever's left, please give the speakers some applause. Please put in some I don't know, I don't know, what do you call them, some smileys or clapping or thumbs up. Please give them any kind of signals really to show your appreciation. I thought this was a brilliant seminar. So I see lots of clapping now. So this really, thanks to Karen, Murtaza, and for Peter for really helping us to understand really. Yes, hydrogen, like anything, many things, does have certain dangers, but if you follow certain procedures, you can live safely, and you don't have to have fear really of endangering other people's safety and lives. I'm sure there'll be more questions, so if anybody wants, they can reach out. We can pass on the messages. But I think with that, I think also very big thank you from my side, and also thank you from the entire Green Hydrogen India team.
Thanks,
you, Rolf.
Rolf. Thanks, Nishant.
Thanks, everyone.
Thanks.
A pleasure, Murtaza. Thank you.
Thanks everyone. Thanks Rolf, especially for being a great moderator.
Yeah.
Thank you.
Good insights, Karan, and
Thank you,
Dr.
sir.
Chitra
Thank you
as
so
well.
much.
It was a great presentation, and the videos were especially very enlightening. Thank you.
Okay.
Thank you for joining us, Doctor. Thank you.
Thank you. Bye.
All right.